Okay, this is where we finished up the notes where we were talking about the bonds, and the dipole bond is between the positive and negative end. Another example of a hydrogen bond, which is even stronger than a dipole. It's a dipole bond, but it's even stronger because hydrogen is so small that when it bonds together, it really forms a strong bond. And again, here's some, I showed you these, but because of that hydrogen bond, you have very high melting and boiling points. They're really a strong bond because of that. So when you're talking about a dipole bond, that's a good bond, the attraction. A hydrogen is a special dipole bond. And the only way you can have a hydrogen bond is if you have a hydrogen in your compound, but it's just a little bit stronger. So intermolecular forces, we have dipoles between positive and negative, and then hydrogen, which is also positive and negative, but it's only with a hydrogen, it makes it a little bit stronger than a dipole. And so the hydrogen bond is a very strong intermolecular. It's one of the strongest, okay? And again, it's because hydrogen, it's just such a small molecule that it forms this extra bonds in between them, okay? So hydrogen bond is like a dipole, but it's stronger than, it's a special dipole bond. And again, you have to have hydrogen in order to have a hydrogen bond, okay? So again, it forms a covalent bond, and you have to have hydrogen in order for it to happen, okay? This is an organic compound, but you'll get that hydrogen bond. And again, it makes the molecules stick together more, okay? Here, they show you in here, you don't have the hydrogen, so you don't have that attractive bond. But again, in order to have the attractive forces in between the molecules, hydrogen bond's the strongest, but you have to have hydrogen in order for it to happen. Okay, and then there's one other force. This occurs in all of them. See, some of them don't have any dipoles because they don't have any polar substances, or they don't have any hydrogen, so obviously they don't have that bond. But every molecule has one intermolecular force, and it's called London dispersion forces. Like if you're talking about a nonpolar substance, or if you're talking about a noble gas, it's the only force because they don't have dipoles and they don't have hydrogen. Okay, so if you have a nonpolar substance or if you have a noble gas, the only intermolecular force they have is called London dispersion forces, and they're not very strong. If you have something that has dipoles and hydrogen bond, they also have London dispersion. So all compounds, when you put them together, in between the molecules, there's one force, London dispersion. Some of them have dipoles if they're a polar substance, and some of them have hydrogen bonding if they have hydrogen. But some of them don't have those, but everyone has London dispersion forces. They're not very strong. They're like instant attraction occurs and then they move again, and instant attraction occurs and they move again. So they're always being formed and broken, formed and broken. So they form a little bit of attraction, but not real strong. Okay, so the instant a dipole, again, a dipole, it's induced and you have that positive and negative. With a nonpolar, because you really don't have that positive and negative, they'll be attracted for just like a sec and then they'll break apart. So again, London dispersion are very weak forces, okay? And generally, as the size of the molecule increases, they form a little bit better because they're away from the nucleus. So the bigger molecules will have stronger London dispersion forces. But again, they're all really weak. They don't compare to like a dipole or a hydrogen. They're not in the same league at all. Okay, so which of these would have the largest London? Again, you'd have to look for the largest molecule, so it would probably have to be this one. It's very simple. The bigger the molecule, the more the London dispersion. Okay, so that one's pretty simple. It's the biggest molecule, it would have the strongest London dispersion. Okay, when you have water is very unique. It has some just cool substances that no other organisms or no other compounds have. It has two OH bonds because you have, H2O, so you have one here and one here, and they overlap to make the s orbitals. But again, remember, we've got this positive end down here and this negative end there, and it makes water very special. And water is a bent molecule, if you remember that from your VSEPR, because there's actually two lone pairs up here. 2 and 2 make it bent, okay? So it has a permanent dipole because of its bent shape. So the dipoles in water are probably stronger than anything else. So it has dipoles, and it has hydrogen bonding, and it has London dispersion forces. So that's why water molecules are so attracted to each other. They have all these intermolecular forces going on. Okay. So water is very unique. There's a couple things. One thing about water that's super, super unique is that as a solid, it's actually less dense than it is a liquid. And it's one of the few substances that does that. And that's really important. Coming up soon, we will have ice on the top of our lakes because ice, solid, is less dense than the liquid. If the solid was less dense, then lakes would freeze from the bottom up. And poor fish, where would they go? It'd be really easy fishing for a couple of days because they'd be plopping on top, then they'd all die. So it's really good, water's unique characteristics because of those attractions. And that's probably the most important thing. Well, two more most important things about water is that when it's a solid, it's less dense than a liquid, so we don't kill everything in the lakes in the winter. And it holds on to heat. We've talked about it before, but water holds on to heat more than any other substance, which is great that the earth is covered with about 70% water because it holds on to the heat during the day and releases at night so we don't freeze to death. Okay, so when we talk about water, again, it's a unique liquid. We can't survive without it. We have a lot of issues because of climate change with water. Our biggest change in North Dakota has been our change in weather. We were really wet. I mean, we had a lot of flooding going on and everything. Now we've kind of switched, and now we have longer growing seasons, but we have a lot of drought. Okay, and that's what some people think climate change is just the world's getting hotter. What's happening is it's getting wetter in some spots and drier in some spots, and we've got these just massive changes in weather. We have more hurricanes, we have more tropical storms, we have more tornadoes, we have more, the weather is more violent, I guess you could say, because of climate change, okay? So there's been some issues because of climate change. We basically have less drinking water available. They call it potable water, water that we can use, because most of our water now is tied up in the oceans with salt water, and that's not something we can use. So we have issues that we have to look at to reclaim our wastewater. Okay, we have a lot of wastewater from agriculture and industry. So what can we do with that? We have to fix it. We have to clean it up. Or we have to take seawater and we have to take the salt out of it. And this is very, very, very expensive. Plus, you need to be near the ocean. We can't really do a lot of this in North Dakota. Okay, so there's all kinds of issues that deal with water supplies, and we have more and more problems with it all the time. We're very fortunate in the United States because we have a lot of water treatment plants so that we have clean water. We take that for granted, and then there's a lot of countries that don't have that. They don't have clean water, and a lot of people die because of water. But we're getting more and more issues because of the climate change. We're losing, like North Dakota's super dry now. We're not as dry as, look at poor California. They're burning up their west coast. They're right next to the ocean and they have all that water, but it's not water they can use. And then it's so dry that everything's burning up. Okay, so one thing they've tried to do with water is break it down into hydrogen and oxygen gas, because both of these would be really good sources of energy. But so far what they found out is the energy it takes to break it down into hydrogen and oxygen is more than the energy they get when they burn it. But there is some of this occurring if you have a hybrid in your fuel cells. It does tend to break down water and then burns these. That's where it gets the energy from. So we have some sources of that, but not a lot. Okay, so that's the end of chapter 13.